Welcome everybody to another live stream. Today's lesson, what we are going to work on is actually cover the analytic trigonometry quiz number 2. So the last quiz we covered, it was quiz number 1, which we basically dealt with simplifying expressions, verifying identities, as well as solving equations. And then on this quiz, this is basically over the identities, the half angle, the double angle, the sum and difference for sine, cosine, as well as tangent. So what you can see here is we have some evaluate when given some trigonometric equations. So it's basically going to be off the triangles. We have another one for the double angle and half angle off the triangle. Then we're going to come up with a verifying one, and then a solving on the terms of 0 to 2 pi. So basically, like what I'll do with the rest of my quizzes when I'm going live is I'll just kind of go ahead and take a break here on the kind of midway point, and then, oops. Oh, come on, don't be doing this to me now. Sorry, just checking something. I'll go ahead and take a break here at the midway point, and then what I'll do is I'll go ahead and knock out some of the multiple choice questions for you guys to go ahead and to take a look at. So, and then we'll kind of go through that. So hopefully, if you guys have any questions or anything like that at the midway point, I'll be able to revert back to it, make sure I can, answer or elaborate a little bit more on why I'm doing some of the, techniques or how I'm getting some of my answers. And then depending on how much time we have after, I will go ahead and answer some questions that you guys are going on in the chat. I forgot to put everything on Facebook. I think what I'm going to do is, put maybe some questions on my Facebook, like at the beginning of the month or beginning of the week, because I basically will be going live every week, and so therefore hopefully I can kind of get some questions to add into after the stream. But for those of you guys that are just joining in, which I see a whole bunch of you guys are, so good to see a whole bunch of names that don't see, but I see Harry, Layla, Kid Math. How you guys doing? Great. Happy to see you guys. So let's go ahead and get started again. And our set of failure quiz. Yeah, it's okay, man. A lot of people did not do so well on the quiz. So that's why I wanted to kind of go through this, explain things, because I don't think it was the fact that people did poorly on the quiz because they didn't understand so much the material. I think they did poorly on the quiz because they didn't really know what to do with some of the problems. So I think once we kind of clear some of that up, that is going to help out a lot as we prepare for the test. So let's go ahead and take a look at this first question. It basically says, given the following functions, cosine of u equals -3/5, where pi is less than u, which is less than 3 pi halves, as well as cosecant of v equals square root of 2, where pi halves is less than v is less than pi. So basically we have two trigonometric equations, and what we practiced on evaluating was we could evaluate either given angles or given triangles, and in this case we have a trigonometric equation. So what this allows us to do is we can create a triangle from this. So let's go ahead and create a triangle. So we have a -3/5. Now remember, cosine is adjacent over hypotenuse, right? So obviously we know that the hypotenuse is not going to be negative. That's going to be a 3. Based on our angles in the unit circle, we know that this angle has to be between pi and 3 pi halves. So we know that the triangle is going to be in the second quadrant, and therefore, so we'll go ahead and write u right here. Here is my -3, and here is my 5. Now, we could use Pythagorean theorem, or we could just understand that this is, again, a Pythagorean triple. But what we recognize here, I'm just going to put this in parentheses because we are figuring this out. That is going to be a -4. And again, it's really important that we understand that's a negative because it's going down. This is one of the main issues that students had when we did this in our trigonometry section. And again, it showed up on this quiz, one of the more common mistakes. So that is for our angle u. Now let's go ahead and talk about our angle v. So again, we have cosecant of v equals square root of 2. Well, remember, sine, cosine, tangent, cosecant, secant, and cotangent are all our ratios. So what are we comparing cosecant? Well, cosine is adjacent over hypotenuse. Cosecant is hypotenuse over opposite. Right? So a lot of times when we have just like just a single number for our trigonometric function, we put it over 1 so we can write it as a ratio. Now again, following the same technique I did with you, I'm going to draw this triangle on this coordinate grid here, and V has to be between pi halves and pi. So therefore we can see this triangle is going to be right there. So there is V. Now again, the hypotenuse is square root of 2, and the opposite side is 1. Well, hopefully what we recognize in this case is that this would be a 45, 45, 90 triangle, and therefore this is also going to be 1, but since it's going to the left, it's negative 1. So again, this hit a lot of students for getting these wrong, and basically they got it wrong because they didn't create these two triangles. And once they didn't create the two triangles, they didn't really know what to do kind of further. Now, the other thing that needed to happen is once you kind of have these two triangles, you have the sum and difference of these two angles. So the first thing that I recommended in the classroom is whenever you see these triangles, you know you're going to have to apply the formula. And we're given the formulas on the board as well as on the formula sheet. So let's go ahead and write them out. So this one would be cosine of u times the cosine of v plus the sine of u times the sine of v. Okay. Now again, we now know we have a triangle of u. So can we figure out what the cosine of u is? Well, yeah, cosine of u is, again, actually, we don't even need to look at the triangle. That was given to us. It was negative 3 over 5. The cosine of v, well, we got to go over here. Cosine, again, is adjacent over hypotenuse. Now, you could rationalize the denominator, or you could just leave it as a negative 1 over the square root of 5. So I saw a lot of students rationalize the denominator, which is not a bad idea. So therefore, you don't have to do it at the end. But again, I'll just kind of do it not, and I'll simplify it from there. All right. So then now we have the sine. So the sine of u is going to be opposite over hypotenuse. So that's going to be a negative 4 over 5. And then the sine of v is going to be positive 1 over square root of 2. So this would be positive 1 over the square root of 2. So now when I multiply these, I get negative 3 times negative 1 is going to be a positive 3 over 5, square root of 5. 3, 4, 5. 5. Oh, that's a square root of 2. I don't know why I wrote that as a square root of 5. I was like, I don't remember that answer there. Okay. So there we go. 5 square root of 2. I was like, that's not right. So let's go and fix that. Come on. So that's 5 square root of 2. Okay. And then plus, this would be a negative 4 over 5 square root of 2. Now, when you go ahead and add these together, you're going to get a negative 1 over a 5 square root of 2, which now you can go ahead and rationalize the denominator if you didn't already do it before. And therefore, final answer is a negative square root of 2 over square root of 2 times square root of 2 is 2. 2 times 5 is going to be 10. All right. So now let's go with the sine. So again, we have the same angle. So once we did the triangles, we don't need to do that again. Now we just got to use a different formula, which again is provided. So let's use the sine formula. So that's going to be sine of v times the cosine of u plus the cosine of v times the sine of u. All right. So again, let's go to the sine of v, which is going to be opposite over adjacent. So that's going to be 1 over the square root of 2. Cosine of u is going to be negative 3/5 plus the cosine of v, which is negative 1 over the square root of 2, and then the sine of u, which is going to be a negative 4 over 5. Oh, I'm sorry, negative 4. Yeah, negative 4 over 5. Okay, so now when we do it this way, we have a negative 3 over 5 square root of 2. And that's going to be now plus, you can see these add to give you a positive 4 over 5 square root of 2. So now when you combine these, you get a positive 1 over 5 square root of 2. And if you rationalize the denominator again, you get a positive square root of 2 over 10. All right. So again, the main important thing I think that students had trouble with this problem was not creating the triangles. And, they just had trouble. I'm not sure. I don't think they have a problem doing the triangles. I just don't think they knew that's what they needed to do this problem. Because then they couldn't do the angles. So that's where they got stuck. And that kind of carried over to this problem. Again, we don't have an angle. We have a trigonometric ratio. So therefore, to evaluate, like, for instance, if I look at the double angle of tangent, right? And again, I'm just going to, so the double angle of tangent is 2 tangent of theta all over 1 minus tangent squared of theta. Now, this one wasn't too bad, right? Because to solve this, all we need to know tangent. And then, therefore, in this case, tangent is 3 over 2. So actually, I don't even need to create a triangle. And this was kind of supposed to be like my gimme to the students here, is just plug in tangent. You already have it. That's all you needed to figure out. Now, I did ask them to evaluate. Oh, that's what I forgot to do. That's what I forgot to change. And simplify. So this would be 1 minus 3 over 2 squared. Okay, so now when I go ahead and multiply this out, I end up getting a 3 over 1 minus 9 over 4. And then there's a couple different ways, you could do this. You can multiply by a common denominator. You can multiply everything by 4 on the top and the bottom if you wanted to. You could combine your fractions in the denominator if you want to do that. There's a whole bunch of, algebraic manipulations you could kind of take here. Let's just multiply the top and bottom by 4. Make sure you apply distributive property here. Therefore, you get 12 over 4 minus 9, which equals a negative 12 over 5. Okay? Now, in the next problem, if we look at the half angle, so the half angle for tangent, just to make sure that I have it correct, which I'm going to use, that's not the one I'm going to use. I'm going to use that one, which is 1 minus cosine of theta over the sine of theta. So to evaluate for the half angle of tangent, I need to know what the cosine is and the sine is. And that's not very obvious if I just know the tangent. And again, this is when sine is greater than 0. So I'm going to go ahead and sketch this. Now, I know sine is greater than 0 in the first as well as in the second quadrant. Tangent is opposite over adjacent, right? And I know that one of these would have to be negative if it was a triangle in the second quadrant. So therefore, this triangle needs to be in the first quadrant. So here's my triangle. Here's theta. And we have 3 over 2. Now, when you apply the Pythagorean theorem, you get 3 squared 9, 2 squared is 4. So this ends up being the square root of 13. So the cosine here is going to be 1 minus the cosine, which is 2 over the square root of 13, all over the sine, which is opposite over 3. So 3 over the square root of 13. Okay, now again, kind of the same thing here. You can get rid of the radicals in the denominator. So I multiply by a square root of 13 on the top and bottom. Just make sure you apply distributive property here. I'm going to kind of work from left to right. Let's keep on going down. We'll do one more. So this becomes the square root of 13 minus 2 all over 3, right? And you could write it like that, or I also accepted and rewrite the square root of 3 in the front, and you get a square root of 13 minus 2. So either way is right. I just kind of was talking to my students a lot about this because this shows up a lot for multiple choice answers. So there you go. So again, another triangle problem. And I think students just had trouble getting those triangles. But I think if I would have given them the triangle, they would have had a lot easier time being able to do these problems. All right, so let's go and look at the next one. And again, this one really kind of confused me where students got this. So for those of you that did this, I am going to post this on YouTube. So therefore, you recognize your mistake and you never do it again because I never taught you this. So we got to be very careful. We had the sine of alpha plus beta, and the number one mistake I saw students do, and I think, to their kind of credit, I think they do these first two problems. They got confused with the triangles, and then they kind of lost some confidence. And then they're like, crap, what do I do here? And then I started seeing students doing this. And this is something that we have never done. And one thing I was surprised I didn't really need to bring up this year, because actually I've never even seen this mistake happen. Like when we've done all the work in board, all the work in class, this is a very common mistake from students that are first learning the sum and difference angles. But I actually haven't seen any student making this mistake yet. And then on this quiz, it like just unloaded. This is never, like never. So we know the sine formula for the sum. Well, guys, I mean, it's right here. Like there's the formula, just different angles. So typically when you're verifying identity, you want to apply the identity. Like if you see a sum or difference, half angle, double angle, like apply the identity and then see what operations you can apply. So on the left side here, if I do the sine formula, this would be sine of alpha times the cosine of beta plus the cosine of alpha times the sine of beta. And again, this is all over the cosine of alpha times the cosine of beta. All right. Now, again, we're trying to get this to be tangent. And the one thing I think about tangent is I need sine over cosine, sine over cosine. And I recognize if I have sine of alpha over cosine of alpha, I have tangent of alpha. If I have sine of beta over cosine of beta, I have tangent of beta. So the only thing left is I need the rest of those other cosines to kind of divide out. Well, just like if I did, 1/4 plus 1/4, that is 1 plus 1 over 4, right? So a lot of times, we understand this common denominators, just add the numerators, right? And then we rewrite it, like this. But again, in the same respect, like if I have a fraction and the numerator is separated by addition and I have just like a monomial in my denominator, I can divide that 4 into both terms of the numerator. And that's exactly what we want to do here. Now, some students also did this, and I'm not sure if they knew what they were doing or not, because they just kind of also like didn't show their work completely. So they kind of like expected me to assume they got the right answer, and they kind of went from like here to the answer. So again, it's just very important when you're doing your identities that you are basically showing how you are going from each step to the next step. Now, you don't need to show the dividing out, but I'll show that, and therefore you can see now here left, I'm showing this like step by step here. Cosine of alpha or sine of alpha over cosine of alpha equals, oops, not equals, plus sine of beta over cosine of beta. And obviously that is tangent of alpha plus the cosine of beta. There you go. Okay, so you can see working on the left side. You also could have done this on the right side. If you would have converted this to sines and cosines and then got common denominators, then you could have converted the numerator into using the sum and difference formula. So that would have been another option for you guys to work on. All right, so then on the next one, again, like looking into evaluating, when we're doing the solving, I think the easiest parts that students need to get here is just applying the formulas. I mean, you're given the formulas, make sure that you can apply them. And I think if you can at least get to that portion, then you have some time to kind of figure out, if you're making a mistake, what you need to do from there. But I think like the first step here is I see the cosine of sum of two angles and the cosine of difference of two angles. So I'm going to apply the formulas and apply them. Now, the other thing I did mention to my students was when you have like a subtraction between these terms, like use parentheses. And we did look at a couple students that were making their mistakes, and it was purely just based off of parentheses. So by applying these formulas here, I am going to get cosine of x times the cosine of pi over 6 minus the sine of x times the sine of pi over 6 minus, I'm going to use parentheses here, and then this would be the cosine of x times the cosine of pi over 6. Now again, remember that is like, notice the formulas for the difference here. It's positive angles. You're just subtracting, like you're just finding the difference between these two angles. But in both cases, these are positive angles. So it's cosine of pi over 6, plus here the sine of x times the cosine of u times cosine of v plus sine of u times the sine of pi over 6. Let's close that parenthesis now. equals 1. Okay, so again, the reason why this parenthesis is so important is because a lot of students, what they do is they'll make this one negative, but then they forget to negate that one. And so I am just going to go through it. I did this in my homework. I did this in class. I'm just going to rewrite everything so you guys can see this. And I know it takes a little bit more time. It's a lot to rewrite. I would not expect my students to go ahead and rewrite this, you know, when they're taking a quiz and stuff like that. Like, you need to be conscious of time that's going on. But for this one, for at least from educational purposes, I want you guys to see what happens here. So obviously we have these cosine terms are exactly the same. One's positive, one's negative. So they're going to add to 0. Here, these don't add to 0. These are both negative. It's like a -3 minus 3. That equals -6, right? You're combining them, like -x minus x equals -2x. Right? So this becomes a -2 sine of x times the sine of pi over 6 equals 1. Now we can evaluate for the sine of pi over 6, which you think pi over 6, you can see that's going to be 1/2. So it's -2 times the sine of x times 1/2 equals 1. Well, now these 2's, you could rearrange these if you want to. Those are going to divide to 1. You're left with the negative sine of x equals 1. Divide by -1, divide by -1. Sine of x equals a -1. So you have the sine of x is now equal to -1. Now we're looking to solve on the unit circle between 0 and 2 pi. Basically, when is the y-coordinate going to equal -1? That's going to be that angle right there. So there's only one solution here, which is going to be a 3 pi over 2. Okay, so I'll go ahead and take a quick little break here, guys, just to kind of check in with you. I have a couple more problems here I'm going to work on for the multiple choice that we can go ahead and take a look at in a second. And so, oh man, got a lot of people joining in. That's cool. All right, Victor, Evan. You just reading my message in the wrong tone. Okay, I guess you guys are just having that. McLogan for life. All right. Hey, Riley. Thank you very much. Victor. Oh, Victor, you're messing with Riley. Watch it there. Roger, and they are the same. Victor, is this confirmed by... I'm not sure, Roger, which... I'm trying to see if you guys have any questions or what you guys are at. Calc and trig are not the same thing. Obviously, there is trig. We deal with trig in calculus, but obviously just the study of trigonometry is not the same as the study of calculus. Okay, so some questions as far as pre-calc and prerequisites and da-da-da-da-da. So I'm not saying they didn't teach you it in calc. I'm just saying calc and RX. Yes. Okay. Wow, a lot of you guys going in there. Okay, so I can't even catch up to your stream, so I'm sorry about that. But I see Crystal, did anyone get 100%? Actually, Crystal, there were 2 students that did get 100%. So yes, they definitely did get into it. So Eternity, no one being a sideline. Jake, cool. Evan, Victor, Colin, where do you teach? I teach in Jacksonville, Florida. So anyways, but yeah, there were 2 students that actually got surprised. So, like, most of my quizzes, it's kind of, most of my quizzes, I would probably say, like, kind of follow a little, like, bell curve. Like, there's, like, that majority that kind of, like, fall in there. And I usually try to stay within, like, the high C, low B kind of range for the quizzes. That tells me, usually based on, like, the my students that, usually I'm aware of, and each class is different, but most of my classes, I feel like around that C to B range is going to be where I can say that I feel like I did what I need to do as far as teaching, and students did what they needed to do as far as, learning. Because all of my quizzes, there are going to be some challenging problems and then some very easy problems. This quiz was a little bit different. I would say the median grade was definitely lower in there, but there was some students that did very well. And again, like, that just kind of goes into, I think if I like prep students a little bit more, I don't think students prepared for this quiz as much as maybe other quizzes. Like they got really off track on these first two questions, really off track. And I think that kind of hurt them along the row or hurt them later on there. But then usually students did fairly well on the multiple choice. So they were able to like figure out the multiple choice ones without showing as much work, which in my class reduced their grade. They didn't get full credit for them because for quizzes they need to show work. So that did kind of hurt a lot of them, but a lot of them were able to kind of figure it out. So, maybe that will show when they take the test, which is all multiple choice. They will do a little bit better. Now, I'm not sure why my answers didn't load here. I think this was like tangent of x, and this was tangent of negative x, or negative tangent of x, which weren't the right answers anyways, so it doesn't really matter. But all right, so 172, you're really not education for them, but I can tell you work out. How much do you bench, man? I'm currently at 305. Well, very cool, and yes, I do work out. I try to go to the gym as much as possible. And I used to wrestle too. I used to wrestle at the 171 weight class when I was in high school. So, yeah, just try to stay fit. It kind of helps me just kind of get in that mind, that kind of mode for teaching, throughout the time. And then obviously if you watch some of my older videos, you kind of see like some differences in like weight and shirts and all that kind of stuff I used to wear. So it's always funny. People like watch my older videos like, oh man, you're skinny. And then they watch like a couple videos like, oh man, you're fat. I'm like, well, yeah, I have videos from all the way back from 2010. So almost 9 years now. I've been going on making videos. So that's like documenting 9 years of my life, which is kind of crazy. Not really my life, but of me teaching math online. It's been 9 years. So yeah, it's kind of cool. Line segments and circles, like just the basics. Victor, it's been a while since I've done some line system geometry stuff. I would have to, I know it'd kind of be hard. What I'd recommend is, we'll look into maybe doing some other live streams where you guys can like submit pictures, because I know in geometry it's really tough. Like obviously you're not going to be able to like type in what your problem is from that, and so what I'd recommend doing is taking a picture and send it to me on Facebook when I put in my next post, and then we can kind of cover that. I mean, the main thing that I would say, or at least the basics idea to give you an idea, is just understanding some segments. And obviously understanding like, your diameter, but also if you have, intersecting segments where they're going to be equal in value. And I'm just going to, I don't know, if I had like 3x plus 1 and 2x, then just setting equations. Like if you're trying to solve, which I believe that's what you're talking about, like with solving, looking into setting up an equation. So there's a lot of things we can look at as far as segments of a circle and, tangent lines and all that kind of stuff. But the main idea is looking at your properties that you've been taught and, definitions and everything, therefore that you can create an equation that you can then use algebra to go ahead and solve. All right. Okay. All right, guys. So I'll go ahead and get into this, and then maybe I'll check in some questions here at the very, very end. So multiple choice questions. All right. Now, again, on this one, a lot of students got this one wrong because they didn't show their work, because we don't know what the evaluate 5 pi over 12 is. And it says evaluate. That means we need to figure out the value. So the one thing I noticed is this looks very similar. Like, let's just call this u, and then let's call this v, plus the sine of u times the sine of v. So when I look at this, like if I, instead of these angles where they're at, if I look at them in terms of u's and v's, I recognize this from my formula sheet as being the difference of two angles for cosine. So if I'm going to say u is 5 pi over 12 and v is 5 pi over 4, then this is the cosine of 5 pi over 12 minus pi over 4. Now, all I need to do now is just get common denominators. So I have 5 pi over 12 minus 3 pi over 12. And that is going to give me a 2 pi over 12. So this is a cosine of pi over 6, right? And the cosine of pi over 6 is going to be square root of 3 over 2. The next one is the sum and difference angle for tangent, which I just want to make sure that I have that again written down correctly. Tangent of u plus tangent of v. I think I got this one. So anyways, this one would be, now this, I actually changed this one, but I'm going to do the original problem for you. I changed this. I was trying to make this easier for my students. So I did change this into, which would have changed the answer, but I'm going to do the original problem so you guys can see how we would have approached this. So I see this as the sum of two angles. So I can write this as, for the tangent formula, sum of two angles, that's going to be tangent of x plus the tangent of pi over 6 divided by 1 minus tangent of x tangent of pi over 6. Now the tangent of pi over 6 is going to be the square root of 3. So therefore, this gives me tangent of x plus the square root of 3 all over 1 minus, let's just write the square root of 3 in front. Tangent of x times the square root of square is 3 times the tangent of x times the square root of 3. Right. Now if I, in the same respect, see that doesn't give me, oh, if I, no, how am I getting that answer? Now I'm getting stuck again. If I multiply by the square root of 3 on the top and the bottom, see, and I thought I did this correct, but now I'm starting to wonder if I multiply by the square root of 3. Let me just double check that answer. Tangent of u plus v is tangent of u plus tangent of v all over 1 minus tangent of u times tangent of v. Right? And that is going to be square root of 3 over 3. My bad. I was doing the problem, actually, our last problem. This is going to be square root of 3 over 3. That's wrong. So this is square root of 3 over 3. Square root of 3 over 3. Because let me confirm this. Pi over 6 is going to be square root of 3 over 2, comma, 1/2. So that would be 1/2 over square root of 3 over 2. Yep, okay. So we multiply all this by. Now, if I go ahead and multiply, that's it. So therefore, I have these two. Now, if I multiply the top and the bottom by the square root of 3, make sure to apply distributive property here. What I will get is the square root of 3 times the tangent of x. Square root of 3 times square root of 3 is 3. 3 divided 3 is 1. And then that's divided by square root of 3 times, or minus, tangent of x times 1. So minus the tangent of x, which ends up giving us answer A. I changed the problem to not make it as confusing with that, and therefore our answer was, when it was tangent of x minus pi over 3, we got answer C. Okay, so the next one is, using the sum and difference angles, and I think this is what students were most familiar with for their quiz, was doing the sum and difference angles, for angles when they're already broken up. So in this case, we have, 120 and then 45 degrees, so we're doing the sine. So let's use red here. So therefore, this can be rewritten as sine of 120 degrees plus 45 degrees. So that is going to be the sine of 120 degrees times the cosine of 45 degrees plus the cosine of 120 degrees times the sine of 45 degrees. Okay, so now we got to know in degrees, sine of 120, well, that's going to have a reference angle of 60. So I know that is going to be sine of 120, that's going to be square root of 3 over 2. Again, it's in the second quadrant, so sine's positive. Cosine of 45 degrees, that's in the first quadrant, so that's square root of 2 over 2. And then that's going to be plus the cosine of 120, that's in the second quadrant, so that's going to be negative, so that's a negative 1/2. And then sine of 45 degrees is in the first quadrant, so that's positive. And then you multiply this, you get square root of 6 over 4 minus the square root of 2 over 4. Get common denominators, and you can see our answer is B. The next one is using the half angle formula. So I say sine of pi over 12. And remember, so if we're going to use the sine angle formula, then we basically have sine of theta divided by 2 is equal to either the positive or the negative radical of 1 minus cosine of u divided by 2. All right, now again, the positive or negative depends on which quadrant pi over 12 is, which is the half angle here, because we're using this formula to solve this, right? So since pi over 12 is in the first quadrant, we don't need to worry about being a negative radical. It's going to be a positive. Now, if theta divided by 2 is equal to pi over 12, that means theta is going to be equal to, multiply a 2 on both sides, you get 2 pi over 12, which would be a pi over 6. All right, so now notice that's a theta, let's use the u. So now for our formula here, notice again we're using theta, not theta divided by 2 inside the formula, right? You're not using theta divided by 2, you're using theta. So we're going to use the positive, so I'm just going to leave it like that. And this will be 1 minus the cosine of pi over 6 divided by 2. Okay, well, the cosine of pi over 6 is going to be square root of 3 over 2. So 1 minus the square root of 3 over 2 divided by 2. All right, and we can see here if I multiply by 2 over 2, then I will get the square root of 2 minus the square root of 3 all over 4, which I can now break that up. So again, if you don't apply that distributive property, then you would get this answer. So we know these two answers are correct. And then you can kind of notice, like, if you didn't want to simplify this all the way, I mean, I'll do it just for so those of you guys could see. You can just take the square root of the numerator and denominator separately. But again, these are separated by subtraction, not addition. So our answer is C. All right, last one, guys, on the quiz, and this was, again, another one that a lot of students got mistakes, and again, it just comes into parentheses, right? So a lot of students saw this, and they remembered, oh, Miss McLogan always says, like, use the first formula first, and then go from there. But again, they didn't use parentheses. So they see the cosine of 2 theta, and they said, well, that's going to be cosine squared of theta minus sine squared of theta. Right? And then they say, oh, the cosines divide out, we're left with the negative sign, and then B was the most missed answer that we got on this quiz. Right? And again, if it just comes down to, guys, being careful, applying your parentheses, applying distributive property, and what you guys can see now is that it's a positive sine squared. These add to 0, so you're just left with positive sine squared, which is A. So for those of the students that took this quiz, hopefully this helped out. Again, a lot of students did really great. I think the students that did poorly just weren't ready and prepared exactly for us. I don't really feel like they knew what to expect, and that could be my blame as well. Like, not pulling. I don't think I felt comfortable that students knew what to do coming into this quiz, and the fact that students didn't do so well on this comes into me that they weren't prepared. And obviously, we can put some preparation on them, and we can put some preparation on me, and we can put some preparation on the quiz too, right? I think if I definitely could have given you some different problems, you would have done better on it. And some of that is design too, is like really testing who did come prepared, like who did do the problems, who did do the homework that I wanted them to do, for the quiz. And those are some of the things that, us as teachers, we want to look at, is kind of seeing, what are students doing to be prepared for the quizzes coming up. But either way, guys, that is enough of my class. Let's just go ahead and check in, see if you guys have anything else I did. It's not helping. SVO, I need help on piecewise functions. He is not answering. Okay, that's because I was teaching, but I can talk about piecewise functions. I mean, that's a big topic. I would also recommend SVL that if you would want more examples on piecewise functions or more things on piecewise functions, to go ahead and check on my live stream that I did. I did a whole homework example on piecewise functions where we go into much more in depth of different types of problems. But I mean, I can go over one example for you and kind of teach that to hopefully do help you out there. And your tube will now split screen with your own screen. Okay. Is this grade 11? It's not really grade. I have students that are in 10th grade all the way up to seniors. So, I mean, this is pre-calculus is what I'm teaching, for you guys. But yeah, I mean, I'd say most of my students are either sophomores or 11th graders. Not as many seniors anymore. Used to. I mean, I took pre-calculus in high school as a senior, but I guess everybody's kind of been pushed a little bit faster and earlier now than they did. So search for what you're looking for in his channel. He might have video. Rajan, yeah, that's usually the case. I teach a lot of the same material, obviously a lot of different problems, but yeah, majority of the stuff for high school, I do have a lot of problems that are very similar. All right. So SVL, if you have some questions on your piecewise functions, like maybe some certain ones, I'll be able to help you out. But otherwise, I will go ahead and do a problem on piecewise functions. I'm not really seeing anybody else that has any questions, so I'll go ahead and give a shot on piecewise functions. And I guess I'll just make one up for you. I'm in 7th. Cool. Eternity. 7th grade. Awesome. I don't really know. I can't remember what I learned in 7th grade as far as my math goes, but but yeah, I think it was like pre-algebra, if I remember correctly, or learning like at least the basics of algebra. I'm not really sure. I don't really remember fully correctly. Trusty says, how's your day going? It's going pretty good so far. It's kind of a little busy tonight. I still got some work to do. So I'm going to work after we get done with this live stream, but let me just kind of do a little quick introduction with piecewise functions, and then, we will, and I'll kind of end it off here because I don't think there's anything else that you guys need. And Trust says, do you have graphing videos for 10th grade algebra? Yes, I have a ton of graphing videos. I mean, just go to my channel, go to my playlist. I have graphing linear equations, quadratics, anything that you need. I have a ton of examples. So, please check it out. And if you need it, just message me. I'll be happy to help you out. All right. So let's say we have a piecewise function. Now, again, like a piecewise function is just a collection of two or more equations. So let's just say fx equals x squared plus 2 plus 1, and let's say x is going to be greater than 0, and then let's do a negative x minus 2 where x is less than or equal to 0. Okay. So first of all, the main thing you need to understand about function notation is here's your function name, f of x. This is a collection of your equations. So these are like your equations. And then these are your constraints on your domain. So the best way to understand this, in my opinion, is just to graph these as two separate equations. So let's graph y equals x squared plus 1. And let's graph y equals negative x minus 2. So if I was going to go up to 1 here, so up 1, and then you can see it's a quadratic, right? So you can see, it looks something like this. And again, we don't need to be exact. We're just going to get an idea. All right. And then we have negative x minus 2. So let's go ahead and graph that one. So that's going to be minus 2 is the y-intercept. And then minus 2 is going to be going down to, to the right one. So it looks something like this. Or you could go up to and to the left one. Go from there. Okay. Now this is graphing two functions on the domain of all real numbers, right? I mean, there's no restrictions on these two graphs. You can just graph them continually. They keep on expanding, right? They're never going to stop. So the piecewise function is basically saying, take these two equations and let's put them together, right? So if we were to do that, if we were just to like merge these two equations, like the piecewise function says, forget about the constraints. If we were just to combine these together, we'd have a graph that looks like this. So f of x from negative infinity to infinity. Well, that might be confusing. Let's just say f of x. Well, let's just say with no constraints. Okay, and if we're just going to draw these two graphs, it would look like this. 1, 2, Here's the graph. And then -2 down here and then up here. Well, the graph looks pretty, right? I mean, it's a combination of these two graphs. The problem is it fails the vertical line test, right? This is not a function. No, it is not a function. So that's a problem. So that means we can't call it a piecewise function because it's not a function. It doesn't pass the vertical line test. So what that means is we need to restrict the domain. And that's what these restrictions are. These constraints are telling us, I don't want you to graph x squared plus 1 for all real numbers. I want you to graph x squared plus 1 for only x values that are greater than 0. So I'm actually just going to redo this. So that means only x values that are greater than, not equal to, but greater than. So that's going to be an open circle. That's going to look like that. And then for negative x minus 2, that's going to be only for x values that are less than 0. So remember, x values that are less than always are going to the left. So I'm not going to graph to the right. I'm only going to graph to the left. So that is what that piecewise function is going to look like. And again, that's really important because if I wanted to say, remember, we can evaluate functions, right? We can say like f of, -1, right? What is f of -1? A lot of students want to plug -1 into both equations like we do with the function. But again, guys, if you look at the graph, like f of -1 is right here. Right? The x-coordinate -1 is right there. You can see that it's 0. And if you were to, actually, I did that wrong. Let's see. What is this? Oh, the slope is -1 over 1, -1. Oops. The slope actually looks like that. My bad. Bad graph. Graph actually looks like that. There you go. So my graph was bad. So therefore, that equals -1. There you go. So you can see at -1, which is right there, you can see down here's that point. It doesn't equal, it's not for both equations. However, here, if you look at like -1, you'd have two solutions, right? Which would mean it wouldn't be a function. So that's where we have to have these constraints. The easiest way that I tell students is to like draw them separately and then restrict them based on their domain restrictions. So hopefully that helped you out with your piecewise functions. And I see some of you guys I'm going to make some more videos soon. Very cool. All right, guys. Well, hopefully you enjoyed the stream. Hopefully you guys had some fun chit-chatting with each other out there and in front of the x-squared. Then that would just be a compression. Trosty's asking what happens if there's a fraction in here. That would just be a stretch or a compression. I would go into, looking into the videos on graphing quadratics. I have a lot of videos where I explain that. Typically, when we're trying to be detailed with our graphing, we're not going to have those stretches and compressions for piecewise functions. Obviously, when you're doing graphing quadratics, using the table, using graphing technology is going to be the best when you have a number in front of the x squared. So either way, guys, I am going to sign off. It's been a great stream. Hopefully I helped you guys out, and you guys have a good night. All right.